Okay, we have something interesting from the UNSW integration read from 2024, problem 13. We have the integral of x to the ln square root of pi e over pi to the natural log of square root of x dx. Okay, now to be honest, I'm really suspicious of this whole integral. First of all, now notice the exponent here on x. This whole thing's just a constant value. If it weren't for this, we could just do power rule on this. The other weird thing is having e inside a natural log. Like if we could break it up, natural log of e is just 1. And then here in the denominator, we've got a base of pi. We usually don't want that. So what I want to do is, I think what I'm going to start with is just start with this denominator and manipulate this. And I'm thinking if we just manipulate this denominator some, we can get some simplification to this whole thing. So first what I want to do here, when we have a situation where our base is not e and it's not x, what I can do for this, if I have some constant a, I can just write this as e to the ln a. So doing that with pi, we would have we could write pi as e ln pi. But we have this exponent, so when we put it all together, this is going to look like, multiplying in that exponent, we're going to have this as e ln pi times ln square root of x. But then from here, what I want to do is just manipulate this square root of x. Let's just write this, I can write this as x to the 1/2. The reason I want to do that is because then I can use the property of the logarithms to bring it out front. But actually, let's just bring it all the way over here. So when I rewrite this, I can write it as e 1/2 natural log pi natural log x. And I could have done this in one step, but let's actually take this 1/2 and put it back, but let's put it on the pi, just using the same property in reverse. So then when I do that, we can write this as e ln square root of pi times ln x. And the reason for that is I kind of like that is going to match this ln square root of pi in the numerator. We have this e here, but we'll deal with that later. But then from here, I can just regroup this. I can write this as e ln x all to the ln square root of pi. But then what we have here, I can use this property in reverse. This thing is the same thing as just x. So I can write this whole thing as x ln square root of pi. So now let's take this and put this back into our denominator and rewrite this whole thing. But first I'm going to rewrite the numerator, but what I'm going to do is I'm actually going to split that up with log properties. For ln pi times e, multiplication I can do as addition here. I can write it as ln pi plus ln e. Just because we determined earlier, that's just going to be 1 there. And then we'll copy this into our denominator. So we'll have x ln square root of pi. Sorry, I forgot the square root right there. And then we'll have a dx over here. But now at this point, we've got the same base in the numerator and denominator. We've got x in both cases. So we can just divide these together and use exponent properties. So when I do that and rewrite, this whole thing is just going to be x. And we'll just write everything out. We'll have ln square root of pi plus 1. When we divide this in, we have this as a negative on the exponents. Well, this is minus ln square root of pi dx. And then what happens from here, we get the cancellation of the ln square root of pi's are gone, and we just have 1 in the exponent. So this whole thing just becomes x to the 1, which is just the same thing as x. Integrate with power rule, we get our final solution of just x squared over 2 plus c, and that's it. So as you can see, they were really sneaky because the whole thing, this whole big messy expression, this whole thing is just x. That's it for today. Thanks everyone for watching. Have a good day.